Hello, ladies and gentlemen. It's time to switch to radians. Once we go radians, we'll probably be stuck there for pretty much most of the semester. So when we start to go through this, we're doing the same thing we did with degrees, but now we're going to just change into a different way of measuring angles. So these are called radians, Radian. It looks a lot like the word radius. And the reason why is because a radian is formed by taking the radius of the circle, whatever that length is, and then laying it along the outside of the circle. So if you take one radius, this length, and you measure it, the angle formed is called a radian. Now you have seen some of these ideas before because you know the circumference formula is 2 pi times r. If I say what's the circumference is the length around the outside of the circle. So how many radiuses would it take to form the outside of the circle? 2 pi r, 2 pi radians. There are 2 pi radians in one circle because it's how many radii it takes to form the circumference. So if there are 2 pi in one complete circle, then there are 1 pi in 180 degrees, a half circle. And then if you want to cut that in half, if 180 is pi, then this would be pi over 2. And if 90 is pi over 2, then 3 of those, 3 pi over 2, would be 270. So these are the quadrant angles. Now we're going to do the same thing we did before where we break it all down. So let's start off with this is either 0 or 2 pi radians. And then across is 1 pi radians. So if you want 180 degrees, that's pi radians. Half of that is pi over 2. And now you can start to think about this as counting in pi over 2s. Let's do this as fractions. This is 1 pi over 2. This is 2 pi over 2, which we never write, we just cancel it out. 2 pi over 2, then this is 3 pi over 2, and this would be 4 pi over 2. 4 pi over 2 is 2 pi over 1. So if you want to think about it as counting by pi over 2s, if it's a pi over 2, that means it's a 90-degree reference angle. 1, 2, 3, 4 pi over 2s. So those are our 90 degrees. Now let's do our 30-degree reference angles. So the 30-degree reference angles, if you think that 180 is pi radians, then if we could probably create a proportion here, we could say pi over 180. Oops, what is that? Pi over 180 equals, let's say, x over 30. If I want to figure out what this would be in terms of 30-degree reference angle, you multiply both sides by 30 and be like, wait, 30 over 180 times pi. 30 over 180 is 1/6. So this is pi over 6, 1/6 pi. Or the easier way to think about it is 180 divided by 6 is 30 degrees. So these are my 30-degree reference angles. Pi over 6 is 30 degrees. Now if you want to count by 30 degrees, it's going to take a while, but we'll get there. This is 1 pi over 6, 30 degrees. 2 pi over 6, 3 pi over 6, 3 over 6 is 1/2. 4 pi over 6. This is 5 pi over 6. 5 pi over 6. And the way I remember that is I think if this is pi, that's 6 pi over 6's. So if I go one less than that, that's 5 pi over 6's. That's a 30-degree reference angle. If you go one more than 6 pi over 6, that puts you at 7 pi over 6. And then you can keep doing the counting by 30 thing. This is 8 over 6, 9 over 6. 9 over 6 is 3 halves. 10 over 6, and then this would be 11 pi over 6. Or the other way is if all the way around is 2 pi, that's 12 pi over 6. One less than that is 11 pi over 6. So if you see something that's a pi over 6, that's a 30-degree reference angle. You just need to remember these 4 angles in radians. Those are your 60s. Let's do the 45s. So the 45s are the ones right down the middle. Try to fix this a little bit. There we go. Okay. So 180 divided by 4 is 45, so these are pi over 4s. I'm going to kind of do what I did before. This is 1 pi over 4, 45 degrees. This is 2 pi over 4. 2 over 4 is 1/2. This is 3 pi over 4. 4 pi over 4, that's 1 whole pi. 5 pi over 4. 6 over 4, 6 over 4 is 3 halves. And then 7 pi over 4. So those are your 45-degree reference angles. Another way to think about this one is this is 8 pi over 4, one less than that's 7. If this is 4 pi over 4, 1 less than that's 3, 1 more than that's 5. Last thing is our 60-degree reference angles. Since 180 divided by 3 is 60, this is pi over 3. Now, 60 degrees doesn't actually hit the y-axis. If you count by 60, you'd go 60, and then this is 120. So this is 1 pi over 3, and then 120 is 2 pi over 3. And then if you added 60 more, you'd be at 180. That's 3 pi over 3. Add 60 more, you're at 4 pi over 3. So that's 240. Add 60 more, you're at 300. That's 5 pi over 3. And then again, this would be 6 pi over 3. 6 pi over 3 is 2 pi. So one thing that people will do is you can count by pi over 6s and really pick up everything except for the 45s. Because if you do 1 pi over 6, that's 30. Here's 2 pi over 6. 2 over 6 is 1/3. Here's 3 pi over 6, 1/2. 4 pi over 6. 4 over 6 is 2/3. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6, 11 pi over 6, and then all the way around is 12 pi over 6, 2 pi. If you count by just your pi over 6s, you can fill in all the other ones. And I think that's how I'm going to do the unit circle here. So I'm going to count by 30 degrees. This is pi over 6. Now this would be 2 pi over 6. That's the 45. This would be 2 pi over 6 because that's 60 degrees. 2 over 6 is 1 pi over 3. 3 over 6 is pi over 2. 4 over 6, 4 over 6 is 2/3, so this is 2 pi over 3. This is 5 pi over 6. 6 over 6 is pi. 7 over 6. 8 over 6, 8/6 is 4/3, so 4 pi over 3. 9/6 is 3/2. 10/6, 5/3. 11/6. And then this would be 0 or 12/6, which is 2 pi. So that gets you all your 30, 60, 90s, but we still need to get the 45s. So this is 1 pi over 4, 2 pi over 4, pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Okay, so those are all in radians. Now we've already done this in degrees, so I'm not going to fill in the degrees. But what you need to realize is these are the same triangles that we did before. So if you're in the first quadrant and you have a 30-degree reference angle, pi over 6 is 30 degrees. Just remember, across from that is 1/2, and across from 60 degrees is radical 3 over 2. So the terminal point, the x-coordinate is radical 3 over 2, the y-coordinate is 1/2. So the unit circle is the same. This is radical 3 over 2, 1/2. And all of the 30-degree reference angles are going to be radical 3 over 2, 1/2. Radical 3 over 2, 1/2. The only thing that changes is in the second quadrant, x is negative. In the third quadrant, they're both negative. And in the fourth quadrant, y is negative. 45. This is a 45-degree isosceles triangle. So the sides are both radical 2 over 2. All the pi over 4s will be radical 2 over 2. 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 The only thing that changes, x is negative. Both are negative. Y is negative. 60-degree reference angle. That means the short leg is the x-axis, so 1/2, and then the tall leg is the y. So all of the 60s are 1/2 radical 3 over 2. 1/2 radical 3 over 2. 1/2 radical 3 over 2. But again, negative, depending on which quadrant you're in. Last thing, the quadrant angles would be at, let's do this in black. This is 1, 0, to go right 1, up 0. This is 0, 1, negative 1, 0, and then 0, negative 1. So there's the unit circle that we've done, but now it's in radians. You definitely need to know every one of these spots on the unit circle for sure in radians and degrees, no problem. Now that's what we're going to practice here a little bit. So let's see if we can sketch some. It says identify the terminal point, and let's see, 3 pi over 4. Pi over 4, first of all, if it's pi over 4, it's a 45-degree reference angle. And the way I remember this is I think this is 4 pi over 4. That's pi. So that means this is 3 pi over 4, one less than that. So we're in the second quadrant, and if it's a 45-degree reference angle, then both of these sides would be radical 2 over 2. And since you're in the second quadrant, x is negative. So negative radical 2 over 2, positive radical 2 over 2. Negative 7 pi over 6. Okay, so negative means we're going to go clockwise. So this would be 6 pi over 6. If you go one more than that, then you're at 7 pi over 6. And you need to remember that anything that's a pi over 6 is a 30-degree reference angle. So that's 30. That means this is 1/2. This is radical 3 over 2. And x is negative. In the second quadrant, x is negative. 4 pi over 3. So 4 pi over 3. Remember, this is 3 pi over 3. So if you go one more than that, this is 1, 2, 3, 4 pi over 3 is down here. And if it's a pi over 3, it's a 60-degree reference angle. So across from 60 is radical 3 over 2. And since you're in the third quadrant, x is negative and y is negative. One more, 5 pi over 2. So 5 pi over 2, let's see, pi over 2 is 90. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2 is up here. So this is 5 pi over 2, which is at 0, 1. So those are evaluating now in radians. We just did that, so I'm going to skip that, but I will do some of these now. If it says, give me the actual trig function, okay, sine of 5 pi over 6. First, you need to find 5 pi over 6. Boom, there's 5 pi over 6. This is 6 over 6. That's 5 pi over 6. So across from 30 is 1/2. The x is radical 3 over 2. And if it says I want the sine, you got to remember the sine is the y-coordinate. So I want the y-coordinate. The sine of 5 pi over 6 is 1/2. Cosine of negative pi over 3. Pi over 3 is 60 degrees. We're going clockwise. So across from 60 is radical 3 over 2. And across from 30 is 1/2. What do we want? Cosine. Cosine is the x. If you think about this as your angle, adjacent over hypotenuse. We're on the unit circle. So the adjacent side is 1/2. The hypotenuse is 1/2. Tangent 2 pi over 3. 2 pi over 3. Let's see. This is 1 pi over 3. This is 2 pi over 3. So we're in the second quadrant. Now tangent is a little tricky. There we go. Okay. This is a 60-degree reference angle because it's pi over 3. So for tangent, you got to do opposite over adjacent. Radical 3 over 2 divided by 1/2. Which means you got to copy, change, flip. Radical 3 over 2 times 2 over 1. It's still negative. The 2's cancel, and you get radical 3, and it is negative. And the way to remember that, there we go. The way to remember that is if you have a 60-degree reference angle, tangent is radical 3. That's the easiest thing to keep track of. If it's a 60-degree reference angle, tangent is radical 3. It's negative because we're in the second quadrant. Secant of 7 pi over 4. So let's see, this is 8 pi over 4. One less than that is 7 pi over 4. Now if we're talking about pi over 4s, that's a 45-degree reference angle, so they're both radical 2 over 2. And secant is the reciprocal of cosine, so 2 over radical 2, which you have to rationalize. So give them a buddy, and you get 2 radical 2 over 2, which those can cancel, and you just get radical 2. So the secant of 7 pi over 4 is positive radical 2. Cotangent of 3 pi over 4. Let's see, this is 1 pi over 4, 2 pi over 4. This is 3 pi over 4. Now, cotangent is the reciprocal of tangent. If it's a pi over 4, it's a 45-degree reference angle. So tangent would be opposite over adjacent, which would be 1. But it's negative, so negative 1. Cotangent would be the reciprocal of that. It's still negative 1. Adjacent over opposite is still negative 1. One more, sine of 3 pi over 2. So 0, 1 pi over 2, 2 pi over 2. This is 3 pi over 2 down here. So I like to label that or repair 0, negative 1. And if they say I want the sine coordinate, the sine is the y. So the sine of 3 pi over 2 is negative 1. So you have a mid-unit checkpoint that should get done. And we're going to do some more radians later. But you need to definitely hit the books. Make sure you know all of these terminal points. And be sure to like and subscribe. So good luck.